Good morning, children. Today we'll discuss about power gain. Let us go with the presentation. Power gain. So it is represented as P power, which is suffix of G here. So power gain Gp of theta comma phi, and radiation or antenna efficiency. Power gain and radiation efficiency. So here if we consider any antenna, so practically the antenna which is made up of the conductor which has the finite conductivity. Hence we must consider the ohmic power loss of the antenna. Whenever we are considering an antenna with a finite conductivity, it has the ohmic power loss of the antenna. If the practical antenna has the ohmic losses, that means I square R, we can represent by P loss. Then power radiated P rad is less than the input power P in. That means here power radiated we can write as P suffix rad. Power loss can be represented by P suffix loss, and input power P in. Here whenever we have the ohmic losses which is represented by P loss, then power radiated is less than the input power. That means when we are radiating some power through the antenna, whenever we are obtaining here some loss, what will happen? Power radiated is less than the input power, that means P in. Then we can express the period in terms of the P in. That means power radiation is equals to eta R into P in. Here eta R is called radiation efficiency of the antenna. Thus radiation efficiency of the antenna can be written as eta R is equals to P rad by P in. But the total input power to the antenna can be written as, how can we write the total input power? P in is equals to P rad plus P loss. Hence radiation efficiency can be written as radiation efficiency represented with eta R is equals to P rad by P rad plus P loss. So power radiated and the ohmic power loss can be expressed in terms of root mean square current as RMS current as period is equals to I square RMS. That means simply we are keeping here suffix RMS. So power radiated and the ohmic power loss can be written as P rad equals to I square RMS into R rad, and P loss is equals to I square RMS into R loss. Then radiation efficiency can be given as eta R is equals to R rad by R rad plus R loss. Here ratio of the power radiated in a particular direction theta comma phi to the actual power input to the antenna is called the power gain. So power gain of the antenna is denoted by G suffix P theta comma phi, and it is given by, so power gain can be given as Gp theta comma phi equals to Pd theta comma phi by P in. So here the maximum power gain can be defined as ratio of maximum radiation intensity to the radiation intensity due to the isotropic lossless antenna. So here this is the maximum radiation intensity to the radiation. So here maximum power gain can be defined as the ratio of the maximum radiation intensity to the radiation intensity due to the isotropic lossless antenna. That means here maximum power can be represented as Gp maximum, which is equal to maximum radiation intensity to the radiation intensity due to the isotropic lossless antennas. So Gp maximum is equal to maximum radiation intensity can be represented as Umax, and here radiation intensity due to the isotropic lossless antenna can be written as P in by 4 pi. But the maximum radiation intensity is given as U maximum, maximum radiation intensity U maximum, which is equals to power radiated by 4 pi into GD maximum, which is equals to eta R power input by 4 pi. That means power radiated is nothing but eta R P in by 4 pi into GD maximum, which is equals to eta R P power input by 4 pi into D. GD maximum, or we can write it as D. So substituting value of U maximum in the expression for maximum power gain, we will obtain. So GP maximum is equals to eta R P in by 4 pi GD maximum by P in by 4 pi, and which is equals to eta R P in by 4 pi. So here this is D by P in by 4 pi. Therefore Gp maximum, which is equals to eta R, GD maximum, which is equals to eta R into D. So for many practical antennas, radiation efficiency eta R is 100% efficiency. Then the maximum power gain is approximately same as the directive T or the maximum directional gain of the antenna. Generally, both power gain and the directional gain are the expressed in disciples dB. Thank you, children.